Hi everyone, I'm Jeff Choate and we are Team 23. Today we'll be showing you our project, which we call Synchrony Post. We worked closely with members of the Care Credit branch of Synchrony, which provides credit cards intended to help clients finance costly medical care expenses. The goal our team was given by Synchrony was to create a system as a proof of concept for their Care Credit app. The system needed to handle invoices and transactions through a mobile application, ideally using some form of touchless payment. As a team, we were given a lot of creative freedom and came up with the concept of a single app used by both the clients and the providers using Care Credit. When logging in, the app is able to distinguish between the clients and providers and direct them to the associated interface. With this, we felt a system of check-ins would be a simple and secure solution to verifying a transaction for both the client and provider. These check-ins can be initiated multiple ways, all of which being wireless solutions, and must be approved by the provider to fully verify a check-in. Now, Peter will tell you more about how exactly we do this.
The first step of implementing the aforementioned check-in process was developing the patient interface. Using near-field communication, or NFC, a user can both check in to their provider and pay without touching anything other than their own mobile device. By scanning a small physical NFC tag placed on provider premises, our application immediately checks the user into the associated location. The tag holds a payload which is read and then processed for security and correctness by the application. The check-in is then used to inform post-visit transactions. NFC is a near-universal technology that is secure, flexible, easy to use, and most importantly, has a low implementation cost. Each tag costs less than 50 cents. Permanent locking keeps tags secure. Additionally, as a fallback for devices without NFC, we also implemented geolocation-capable check-ins. Next up, Tony will be talking about provider-specific features.
The next feature we implemented is a provider-specific interface and experience. We want the Care Credit app to be a one-stop shop and replace some of the systems providers might be currently using. To do so, we made the app capable of detecting if the person logged in is a provider. If they are a provider, they will be able to access two exclusive pages. Since requests are sent to a provider when their patients initiate their check-ins, providers are granted the ability to review the list of patient requests and use intuitive swipe gestures to either accept or deny the patient, which will promptly send a notification back to the patient with further details. Providers will also have access to the invoice builder, which conveniently autofills most of the details with information that was already gathered during the check-in process. The bill goes directly to the patient through the Care Credit app, and the patient will be able to pay using their Care Credit account and NFC. Next, Yusuf will speak on a recommendation system.
We took this check-in functionality and extended it to add more value to the project by developing a recommendation system. After a user has built up an accumulation of check-ins at various locations, we are able to serve recommendations based on proximity and visit patterns. The form is fairly simple. We start with a set of all in-network locations within a set radius, and within each family of professions remove locations that the user has logged visits to a provider covering that specific specialty. For example, if a user already has a designated optometrist, we will prune optometrists from the set of recommendations and instead suggest services not already used by the patient, for example, dental care. Secondly, by analyzing check-in factors like number of visits, variance in the period between visits, and the time to the next appointment, we have a machine learning capable scoring system that predicts when and where a user is most likely to next check in and schedule an appointment. Synchrony could continue to build on these features. For example, calendar integration could sync these appointments to a mobile calendar if a user confirms a recommendation. Finally, Joey will talk about some of the backends supporting the system.
To accomplish all of the app functionality we discussed, we needed to develop a set of robust, secure, and scalable backend services. We architected our backend to be composed of multiple microservices, which have different responsibilities, such as responding to client API calls and performing recommendation predictions. This backend is all manageable from a fleshed-out web interface. To make the system work was non-trivial. For one, we needed to mock Synchrony's production environment, since we could not access any internal APIs or technology. We also needed to learn quite a bit, such as how to develop NFC-capable Android apps with Kotlin, and how to develop a scalable and secure backend using tools such as Spring, Firebase, Docker, and many more. It was a quick ramp-up period, but we were able to meet and exceed our sponsors' project requirements. We'd like to conclude by thanking our sponsors at Synchrony, Connor Jackson and Quincy Chapman, as well as our advisor, Professor Shin.